See, there's some more dad humor.
The live stream is up, so you're welcome to kick it off.
All right, thanks everyone for joining. Quick housekeeping items before we start. Our speaker of the day, Ken, has 35 years working in the insurance industry as an architect, and he's worked with large carriers, vendors, and now AIS, an advisory organization. It's a pleasure to be hosting this session today. Ken welcomes questions during the session. So if you would like to pause and ask, please unmute yourself. But if you're not speaking, please mute yourself through the session. And just a bit of introduction for this session today is so every time there's a natural catastrophe or a pandemic or a hurricane or an earthquake or something like this strikes, state regulators require or ask for insurance carriers to send them the data about the affected properties. This data helps regulators model risk, monitor the market activity, protect consumers, and plan for future emergencies. And God knows that since 1980, United States has suffered more than 250 extreme weather disasters, causing more than $1 billion in damage each. But these are ad hoc reports that come on top of routine quarterly and annual statistics, and there is no good way to present that data. So when AIS invited carriers and regulators to brainstorm, a solution was created. It's the blockchain network. So since 2018, AIS has operated the first blockchain system used to gather the data from across the US insurance industry. So Ken, with that, I open the floor for you. Take away.
Okay, so as David mentioned, questions are welcome. We're an insurance industry. This is not just an insurance solution at the end of the day. So if I'm going in the wrong direction, just ask a question, get me going in the direction, answer any questions. Make sure you're getting what you like out of this. I'm going to try to focus on we're using Hyperledger Fabric for solving a very important problem. So if I steer away from that, just let me know. Okay, so openIDL, why are we doing openIDL? There's a couple of main use cases that Jyoti pointed out. There's this thing called a data call, where a regulator in the insurance industry needs to get some information about what's going on out there, how many people are covered for different things, so that they can put the proper precautions in place ahead of catastrophes, et cetera. So that's kind of an ad hoc need for data where a regulator or Department of Insurance is trying to find out what's out there, and they're asking the carriers to provide them information. Another one is statistical reporting. AIS, as you'll see in a minute, is a statistical reporter. We provide data to the departments of insurance about how much insurance is out there for different carriers. So as I mentioned, there's other applications that can be used. You'll see at its base, it's Hyperledger Fabric and can be used for a lot of different purposes. It's mainly, it's probably the biggest win we get out of openIDL is improved data privacy. And hopefully that'll be illustrated over the course of this discussion. So I'm going to show you from a high level what we're doing, why, do you a quick demo just to give you a sense of how it hangs together, and then we'll go in all the bubble charts and things to show you some of the architecture decisions made and how Hyperledger Fabric fits into this picture. So here's a couple of places that you can see what's going on with openIDL. There's the www.openidl.org. There's also the wiki, where we're slowly putting more and more documentation on the system out there. And we have a Git hub repository on openIDL-org. So we are currently, we just transitioned to a Linux Foundation project. So it's all open source. While we're working with carriers, et cetera, the software itself is open source. The data is very much important to these customers, and they don't want to share it. And that's why we're doing openIDL. We're using very stable technologies underneath, and Hyperledger Fabric is one of those. And the biggest takeaway from here is this true data privacy is what we're enabling is for carriers to provide data in a standard way as efficiently as possible without sharing data they don't want to share. So this, what you'll see today is set in the insurance world. On the first scenario I talked about, the data call, where a regulator is trying to look for information. So that's the backdrop for all of the demo, et cetera, that I'm going to show you today. So let's give you a quick introduction to AIS. AAIS, which Jyoti, as everybody first trying to say it, stumbles a little bit. It's the American Association of Insurance Services. We're 80 years old, probably 90 years old now. Been around for a while. We're a nationwide agency that does three main things: statistical reporting, when carriers have to report their information to the regulators of how many claims and how much premium they've gathered for different lines of business. We do that on their behalf. We're also a rating bureau. We provide loss costs, which are the sort of the base number used to come up with premiums. We do that with data that we are given by our carriers, and so that we can understand the kind of actuarial, we use the actuarial data to provide these loss costs. And then an advisory organization, we provide forms and manuals and other information about these products. So for example, for an auto product, we provide all the forms, et cetera, that you might gotta get on your auto policy. And the reason we do that is because some small carriers or brokers or whatever might not have the desire to do all of that work. We do that in a standard form. We have a lot of experience. We provide forms that they can use, or they can change them, et cetera. So these are the three main things that we do. We're not for profit, unlike our largest competitor. We're doing it on behalf of the insurance industry, and we do it very efficiently. Okay. So what are the challenges that we're trying to solve with openIDL? The recurring problems, the data owner, in this case, an insurance carrier, wants to keep their data private and in their control. But if they have to constantly send data across to regulators, then they're losing control of that data, and they don't want to do that. They want to know that the data that they are sharing is managed properly. It's an auditable process, and they want to make sure that they understand what's going to be done with the data when they provide it. So why openIDL? Insurers get that data privacy. Regulators get reliable and timely information that they're looking for. And AIS, we also get a big win, right? We're doing this for a reason too. We currently store a bunch of this data in order to report it to the departments of insurance. With this openIDL model, the data never, the raw data never leaves the carrier, and so we don't have to have all of it on hand all the time, and that saves us a lot of cloud bills. So the openIDL network, it is a network of four main purposes. There's the owner, and a carrier will have data that is used as the source for something like a data call. There's the government agency that needs to get the information, and then the AIS, who provides support in this interaction. And so you can see, if you know Hyperledger Fabric, there's a couple of different connectivities between these different organizations. As we'll mention later, we use channels for that, right? The Hyperledger Fabric is a really good fit for what we're trying to do. This was all stuff that Truman would have done and would have taken a little more time because he can go into more depth. But so let's talk quickly about the architecture of the system, and then I'll do a demo, and then we'll get into some more details. Are there any questions of interest yet, Jyoti or David?
No questions yet, but I have one, Ken, really quick, from in a standards point of view. So every industry is struggling towards standardizing, whether it is tokens or protocols or for interoperability, for future adoption. So is the openIDL also geared towards implementing any standards, or are you?
Yes, I do have a slide for that. You're giving me a sort of a 4-slide segue, about four or 5 slides from now, I'll get to that. There is a data format that we rely upon and will become a standard over time, because at some point you've got to agree on the format of the data in order to have multiple carriers participate in a common extraction of that data. So yeah, so the standard that we're developing right now, it's a data standard for what we call the harmonized data store, and that'll become more apparent as we go. So absolutely, there's standards. And Dina, I don't know if Dina's on this call, but Dina is our person inside AIS responsible for that, and her information I think is later on in the presentation as well. Okay, so let me give you a quick overview of what the architecture of the system is, what the different nodes are. So we use the term node to represent the full package of openIDL for a particular purpose. The 3 main purposes are for, I'll go through them individually, but you can see that there'll be many carrier nodes. There's usually one sort of what we call an AIS node and an analytics node. The multi-carrier node, or the AIS node, is used by multiple insurance companies who don't want to step up to having their own node. And also AIS and regulators use this node to create and manage data calls and other requests for information. The carrier nodes are, and this is one of the most important aspects of the openIDL, this is a distributed network, in that this node here is hosted by the carrier themselves, right? We provide them all of the scripts and startup to get a node started and connected into the network, provide them, create the certificates, et cetera, necessary to create the organization and connect into the different channels. So they host that, and that's why data privacy is one of the main things we've accomplished here. Is the data that is their raw data is in their cloud, not visible outside of their cloud. And so each carrier will have their own node, and therefore their raw data will be managed only on their node. I gotta speed this up a little bit. And then the last thing is in a data call, as we create data calls and the carriers respond to those data calls saying you can use their data, the regulator can see the results of their data. It all goes into this analytics node where it's combined and the report is created and sent out. That's all part of the standard data call process that we do today, where we aggregate all the information from across multiple carriers. So this is the very high level view of the system. Let me go into each type of node, give you a little sense of what's in there. So this is the diagram as it stands in IBM Cloud right now. We're moving all of our stuff into the Amazon Web Services Cloud with use of, I saw Isaac on the call. We're utilizing ChainYard to help us migrate this application, and it's gone really well so far. So thanks, Isaac, for for joining. And just a quick call out that Chainyard and other vendors are part of the community and are available for carriers to utilize as they start to connect into this network as well. So carrier node is going to have a couple of different things. A carrier and this multi-carrier node are going to have a database where we capture the raw data. In the multi-carrier node, that's not nearly as private as when you have your own node, but for small carriers, it might be fine. They put enough data here to get the job done. And then, of course, there's some cloud specific services that are required to make this all work. Like when you're connecting into an application, you need to be authenticated. You need some sort of authentication for that cloud. And because there's applications involved in here, right? These applications are running in a Kubernetes cluster. There's an application for loading data, and there's an application for managing and responding to data calls. And that's all inside a Kubernetes cluster, as I mentioned. It's just JavaScript, Angular UI, the JavaScript backend. And these applications, the API specifically, have access to the network through the Hyperledger Fabric API. So Hyperledger Fabric is running its components for this particular node in another cluster, and these APIs call to create transactions, put stuff into the ledger and get things out of the ledger, et cetera, and also interact with the private data collection. So the carrier node is very similar. Apps and data loading capabilities, some local services for that cloud provider, and jacking in again to the network through a cluster that's hosting the Hyperledger Fabric components. So the last type of node, which is different than the other ones, is the recipient of the process when all the data is consented, and I'll discuss that in a minute, the details of that. It's aggregated here. There's some listeners to the ledger that say, we just got some data in, you can do your report. It runs the report, puts it somewhere. This is representative, not each analytics node may work just slightly differently. So we've talked about the three kinds of nodes, one for multiple carriers and one used by AIS and the regulators. That's the multi-carrier node, a carrier node, which is one per carrier. And those are all hosted by the carriers themselves, carrier being an insurance company. Sorry to use the insurance lingo. And then the analytics node, which can be hosted by anybody. And for now, we're hosting that. AIS. So the life of a data call is a regulator creates a data call and puts it out onto the ledger. The different carriers see that call and then do something to say, I'm good with responding to that data call. I'll provide you an extract of my data, and that'll be put onto the analytics node and reported. So, okay. So let me go through the scenario real quick, then I'll do a demo, and then we'll get into the architecture, how we support this functionality. So the first step in a data call is for the carriers to load their data, right? So this harmonized data store inside their cloud is going to hold all of the raw data that includes much more than they really want to share. But it's put into a format, as you mentioned, Jyoti. This is the format for this is the standard that we establish so that when a carrier puts their data in there, it's in a format that when we need to report on it, we know exactly how it's organized. So we describe this standard, and there's a working group in the Linux Foundation for managing that standard. And if anybody wants to contribute to the standard, more than welcome to participate in that. Some contact information at the end. So regularly, weekly, monthly, quarterly, the carriers are loading their data from the transactions that happen, right? New people create new policies, they have claims, et cetera. This gets loaded into here over time. And then a regulator using the AIS node will come in and create a data call. It says, I'd like to see how much insurance we have for hurricanes and South Carolina, creates the data call, and that gets put onto the ledger, right? So we hadn't put anything on the ledger except the knowledge that data was loaded in this first step. But in the second step, the data call itself is just a simple JSON document that has text about what we want to get out of this data call. That gets put onto the ledger. So I'll show later. It's hard to show too much on the right amount on a single screen, but there's two channels happening here. One, right now we're using what's called the default channel, where all of the carriers and the AIS node are all in the same default channel. Therefore, they're sharing a ledger, and the data call is put onto that ledger. So at this point, once it's on here, this UI, which is very similar, will show all of the data calls that are currently in the ledger, and the carriers have a chance to read, what is it you're asking me for? You're asking me for hurricane coverage and such. What data fields do you want me to share? Those kind of things. And at that point, they'll say they like or unlike it, meaning that this is something they could respond to, or if they unlike it, they might send a note over to the regulator and say, that's crazy, we can't reshare that data. We need to change this a little bit. And we'll go through this process of creating new drafts of the data call until everybody's happy. So once there's enough carriers that say this is a good data call, we'll do an issue of the data call. The regulator will see that everybody likes it. They'll issue the data call, and now it's the request itself is not changeable, but it's not quite executable yet, right? Because what a data call in the end of the day wants to do is access this data base, this private data, turn it into some sort of shareable data that we can get over to the analytics node. So let's see how that happens. When the regulator issues the data call, it goes into a state where we can create an extraction pattern and attach it to that. So the extraction pattern right now is a map reduce, right? So in Mongo, there's the ability to do a map reduce. You give it 2 JavaScript functions, it converts it into a different collection, and the results are there's some aggregation and some keys created. So all the extraction pattern is 2 functions, a map and a reduce. Those 2 functions are stringified and put into the data call and put onto the ledger. So now on the ledger, we not only have the data call verbiage, but we have the actual code that will execute should a carrier consent. So this is a real important aspect of this, that the carrier, when they consent, will have a chance to see the data call, what's going to be executed against the database. They have actual code, the map and reduce functions. They can pull that, download that, they can test it, make sure it will do everything they expect and nothing they don't expect. And if it's true that they're happy with it, it represents the data call, they can then consent. That's an event that goes onto the ledger so that there's evidence of who's consented. And as a result, a listener will say, oh, they consented, I'm going to now run the extraction pattern. And the execution of the extraction pattern is basically on every consenting node, that extraction pattern is loaded up into a program, sent to Mongo. It runs the extraction pattern, and the results of the extraction pattern are put into the private data collection. So we're, again, depending on Hyperledger Fabric to share the data. The private data collection is on a channel that's connected to the analytics node for each carrier node. And so the data shows up here, and then the report can run. I have diagrams in a little while that illustrate all this again. So hopefully that's not too big, but that's what's going on from a high level. So the actual extraction pattern itself, when the carrier consents to the data call, the extraction pattern is retrieved from the ledger, right? We put it in the ledger, and then the extraction pattern is run against the harmonized data store. And at the time this is run, it has the ability, because it's on the carrier node, to correlate private data with other data. So in this case, we did a proof of concept to show some carriers how this could be done. We wanted to correlate the address with PPP data. so that we could tell, well, how many of these policies are for people who need a PPP data, right? So do they need coverage? If they've got a loan, they may not need coverage, right? So so this is possible with this architecture because the time we're correlating this data, we have access to the address because we're on the carrier node. If we were to run this in some other part of the architecture, we wouldn't have access to the address because carriers will not share the address. So because we're running it on their node, we have access to the address, we can correlate the PPP data, and we can share the PPP correlated data in an aggregated fashion, and the address is never shared. So we're able to use the address without sharing it, right? So that's a superpower that this provides. Previous to this, every carrier would have to do all that themselves in their own way, right? But now we're providing a consistent way to do it and in a private way where they don't have to share data that they don't want to share. Okay, so the results of the extraction pattern are put into the private data collection, and that's on the chain, it's on the channel that's connected to the analytics node, and because the way Hyperledger Fabric works, it automatically gets put onto the analytics node in a private data collection over there, and analytics tools have access to that data to run reports. Any questions so far? We're halfway through. I'm going to go through a quick demo, and then we can go into the details.
Hey, Ken, well, there are a few questions in the chat. If you're
Okay.
good, I'll read them out to you. Okay, let's see. Vincent asks, are there any smart contract examples published standards such as ERC20 tokens kind of look?
So okay, so let me just answer the smart contracts are all CRUD here, right? Most of the secret sauce to this application is outside the smart contracts. We update and read from the ledger and push to the private data collection, but those are just very simple smart contracts. We haven't actually changed the smart contracts in a year and a half.
All right. Sanket asks, is there only one channel and you're using private data collections, or multi-channels and then private data collections?
Yeah, there's two kinds of channels. There's the default channel that connects pretty much everybody on the network. And then there's a peer-to-peer channel for every carrier to the analytics node, so that when they actually get their data extracted, it's on a private channel with the analytics node.
Sounds good. And is managed service being used for this?
So we're moving over to Amazon. We're not using a managed service. We are considering creating some managed service for these things. We know that the Amazon Kubernetes managed service doesn't go cross-cloud, and they need to do multi-cloud. So, so right now we're not doing any managed services. We probably will provide a marketplace component as we make this available in a more open way. As of now, we've been building with infrastructure as code, but it's more sort of as we go, building each node in its own way without managed services. But we look to get there, and ChainYard will be helping with that, among other vendors as we go.
Great. The next question comes from Vladen. Have you considered IPFS, interplanetary file system?
I would have to say that's a question for ChainYard. As of now, we don't. I don't know where we would use that. So I'm happy to have a follow-up conversation. We've used S3 a little bit, but that's so one of the tenets of this architecture is to be multi-cloud, and therefore as agnostic of the cloud as possible. So we're trying not to use S3 per se as a place for files, but IPFS, where that would fit in the architecture, I'm not sure. We'd have to have a separate discussion. So sorry, I couldn't answer that one.
Okay, this question from Isaac. He asks, did you harmonize data standards get developed as part of the openIDL project, or did they exist prior to the project?
Yeah, prior to this project, we had something called statistical plans, which is how we would capture data from our customers. They're very old. We wanted to modernize those. And as part of the modernization, we're defining those standards as we go as part of the openIDL. Yeah, we do try to base it on other standards and point to other standards, but there's all kinds of things that are outside my sort of expertise as to whys and what fors of how those standards will be developed.
Sounds good. Shashank asks, what's the compelling reason for using Hyperledger? Or could we use something like EOS, asks Vincent. It's a follow-up.
Yeah, so it had an earlier call where one of the carrier architects like, why are we using blockchain? You just want to use the term, right? And the answer is, it's funny, I was that person inside AIS, right? And I was like, why are we using blockchain? We could do this ourselves. So blockchain has some inherent trust associated with it that if a carrier comes along and hears the word blockchain, they know there's something going on there about privacy and trust, et cetera. Hyperledger Fabric is an open source, well-known thing that does this pretty well. I'm not going to tell you that there's not a better option for what we're doing here. It fits well, and I don't think we're overusing it. And as we get into the diagrams, I'd be happy to get feedback on, like, you didn't really need Hyperledger Fabric for that. And the answer is clearly we didn't need to use Hyperledger Fabric, but if we built it ourselves, then that would be a red flag for a lot of people. But some of the other technologies, there's a history to any project. To the people who initially built the system, they use Hyperledger Fabric, and we haven't seen a reason to change course on that. But so if that's in the chat, I'll want to look up that particular. I don't think I'm familiar with that particular framework mentioned there.
There are a few more questions, but maybe we can table that towards the end. And
yeah, we'll get into more detailed pictures, which we all like to see. So let me do a quick walkthrough. I'm not going to do the full flow. It's like a 10-15 minute flow, but I'll give you a sense of what's going on at any one time. All right, so the first step in the process is for a regulator to create a data call. So this is the AIS node we mentioned before. Sorry, AIS node. Right, so the name is indicative up here. So I'm going to log in as a regulator. Right, so I have credentials. I'm part of an organization. I'm looking in the default channel now, and I see these data calls. These are the draft data calls, and then there's some issued data calls. These are all things that are on the ledger, right? So I am getting these from the ledger. There's some room for some UI improvement here, but basically a regulator comes along, creates a draft data call, and now this is visible to all the carriers, right? So when a carrier logs in, and I will log in as this carrier here. Again, carrier is an insurance company. I just use that. But so they see these same draft data calls. They can go in, take a peek at it, and say, yeah, I see what you're trying to do, right? This is all verbiage at this point, right? There's no code to run, but this is something that's been put onto the blockchain, and I, as a carrier, can say I do or don't like it. I can click this to like the data call, and then when the regulator comes back in and looks at that, I know there's a little bug here. They'll see that likes increase, and eventually they'll say that's good, and the regulator at one point will say, I'm going to issue this, right? So there's a few functions here available to the regulator because of their role that aren't available to a carrier. They can create new data calls, they can issue, et cetera, right? So so this here, while we're running it in our own cloud right now for a proof of concept purpose, this is the code and the whole node that would be running inside a carrier's cloud, right? This would be on Amazon or Google or Azure and maybe the IBM cloud. We don't get a lot of calls for IBM cloud, but this would be running on their cloud. So once enough carriers are happy with it, the data call is issued, and once issued, the data calls are available for consent. Right? So up to now, a carrier hasn't done anything to say, I want you to use my data. They have to look at the extraction pattern. So here's the extraction pattern. I can look at what the code was written to implement the language that we saw. Let me just say this real quick. So the code, it can be very complex, but it's really just, like I said, a MapReduce function. So this is just a way to share it as a string. So a carrier can take this and say, oh, I see the map function, I see the reduce function is down in here too, and take this code, put it into their development environment, point to their database, run it, see what would result, because it's just a standard way of executing something against Mongo. And they can basically test it and verify that it is what they expect. And once they agree that it is what they expect, sorry, do it again, do that. Then there's a consent. I've already consented to this. There's a consent button over here that says I consent to that. And at that point, the consent will run the extraction pattern against their Mongo database. So let me give you a quick look at what the Mongo database looks like. So this is just a little test database that I use. So this is the insurance carrier's data. Right? This is what they actually have provided in here. So let me just expand this guy. Yeah. So here's information that is private for the carrier. For this particular policy, they have provided an address that they don't want to share with the regulators. But when we run the data call, we do want to use that address to see if there's a PPP loan associated with that. So when the extraction pattern ran, it results in another collection. And that's what this collection is basically taking that input data, running that code you just saw, and then giving results. And the results of those are, there's no address in these results, right? There's some key information and some aggregated information, but there is evidence of what the address was used for. Come on. Which is this PPP information. You can see here that we were able to use the address. We don't share the address itself now on the output, but we use the address to find the PPP loan. You know, the loan, we can get the loan number, et cetera, but we can get how much the loan was for, some race information, all kinds of extra information that the address was used for, but didn't share the address, right? So it's really important. So then what happens is one of the components in the carrier node will then take this collection and put that into a private data collection. Private data collection goes over to the analytics node, and then the report can be executed. And then after a certain period of time, we throw away the data on the analytics node. So I know that's not the full-fledged start to finish demo. It's too long for this purpose, but you get the idea that there's different roles. There's carriers, there's AIS role, there's a regulator role. So the AIS role was, we are the ones who put the data call, the extraction pattern into the data call. And then the carriers consent and like, and the regulator creates and issues the data call. Okay, so sorry about the quick demo, but I do want to show why we're using Hyperledger Fabric, because I know that is the main purpose we're together. So, it's not all about Hyperledger Fabric. This has got a lot of basic requirements, architectural requirements that we need to cover off. So I'm just going to throw those out real quick and try to answer how we hit these after I go through the diagrams. So trust immutability, right? It's very important that the carriers trust that their data is not going to be messed with. And if they do something that nobody can change that, like when they consent to something, somebody can't say they didn't consent. It needs to be performant, of course, it needs to be secured. It's got to be permissioned. We need to know who's in this blockchain network. That's why we're using Hyperledger Fabric. It's a permissioned network. It needs to be distributed. We're going to have nodes that are not running in our cloud, and that other cloud could be AWS, could be Azure, could be Google. It might not even be a cloud. I'm not sure we want to support the non-cloud sort of running on on-prem model, but it's definitely a possibility. And it needs to be manageable. So when I talked about the PPP aggregation, there's a lot of different data sources that might be pointed to. Maybe it's just a call to a URI, maybe it's a whole data set, maybe it's a component that needs to be added. We need to be able to manage nodes that are distributed. We need to be able to go to that carrier and say, we need to give you a new version of openIDL that gets installed in your cloud and runs the way we expect, right? So it's a very important part of this process too. It needs to be transparent so that when we tell a carrier that we want to install new things, they need to be able to know what's being installed. They need to know what, so not only on the provisioning of the infrastructure, but also all of the different aspects of the interaction. It's all in the ledger, and nobody's hiding anything. There's no secret things going on as far as the correspondence between the different people on the network. And then keeping the data in place is really one of the main reasons we started looking at openIDL. How can a carrier keep their address but make it usable for connecting to other data, and how can we keep that from data from going across the network that doesn't need to, right? We don't want carriers to have to trust us not to use their data for other purposes or have some sort of breach. We don't want the data at all, right? So keep the data that's private in their world and never share it. Okay. So the application architecture kind of gone through a little bit of this, right? It's using distributed ledger technology, the Hyperledger Fabric, so that anything we're doing with other carriers or nodes is all managed and evident on the ledger itself, and any data that goes across to the analytics node or et cetera will be using private data collection. So this is not code we wrote, right? We're just building on top of Hyperledger Fabric. We know everybody on the network is permissioned and has the right certificates and everything. The code themselves is running in a Kubernetes cluster. It's just Angular JavaScript UIs with some Express JavaScript services. Those services do have access to the Hyperledger Fabric API, and they also have access to the harmonized data store that's local, and what other cloud services might be necessary to keep things cognito, other things in Amazon. And the extraction pattern, as I mentioned, is run by this data call processor, and it's basically just a MapReduce function for Mongo. So how does the data flow? The carrier data is something that we don't control, right? So the harmonized data store is the data in the format that we understand. This carrier data, we don't know where that comes from, where they keep it, but we help them to build a mapping layer, right? So we're going to provide, we provide the scaffolding for creating this output, but we don't know what the input is. So the carrier is responsible for doing the mapping into the harmonized data store, from their carrier data. So this is unknown format. This is known format. They use the API to load that data into the harmonized data store. They would, as I mentioned before, the data calls, et cetera, are all captured in the ledger itself using simple CRUD chain code, put, get, state in the world on the ledger, and that's on the default channel. And when the extraction pattern runs, it's going to access the harmonized data store, put data into the private data collection, which is shared across the analytics-carrier channel, right? One private channel for each carrier with the analytics node. And if there's multiple analytics node, there'll be multiple carrier analytics channels. So that ledger is not visible to the default at all. And the private data collection pushes across to this node, and then the data, whatever has to happen on that data to create the proper report, is basically different for every application. For data calls, it'll be one thing. For stat reporting, it'll be another. So that's the application pieces. That's a bigger picture of that. So technical architecture. So we need to be multi-cloud. We're using Kubernetes and Mongo, and then there's some services specific to the cloud. This is kind of an in-depth look. A little bit more in-depth. There's an even deeper level, of course, when we're talking about all the different pieces of Amazon Web Services that we're using to provide that. But these are all the different nodes and the different channels that they contribute to, and all of that application. So the interaction between the nodes is all Hyperledger Fabric, right? There's no open chat channels or anything like that. If that's happening, that's outside our application on Slack or something else. But no data is going across any other way than through Hyperledger Fabric. And here's a sort of a detailed picture of how the architecture is getting mapped into Amazon. This is one of the deliverables from Chainyard, helping us define how the Amazon Web Services are used to provide this, to support the system. Okay, so DevOps is something we're working out as we go. And our question earlier, do we use managed services? I was just having a conversation earlier where we might create we might decide to create an Amazon managed product, right? That is the openIDL, which includes the Terraform, et cetera. So our current process is for all of the applications, we're building them, pushing them out to a GitHub container registry. The GitHub Actions, we'll build those and make sure that they're there and versioned. Then Terraform is used to set up the infrastructure pieces in whatever cloud is being used. We've got a bunch of credentials that need to be kept somewhere. We're looking at Vault for that purpose, trying to stay cloud agnostic with the management of the secrets. And then one of the things provisioned is there's 2 Kubernetes clusters provisioned as part of Terraform. The publishing of the pieces into those clusters is done with Helm and Helm charts that get those public images and put them into the Kubernetes cluster. And we're thinking about using GitOps. So we're in analysis right now and working with Chainyard to decide what's the best way to make this manageable so that as we need to provide new components or updates to components, what's the best way to provide that to our distributed nodes. So that's the DevOps picture. So how are we addressing these particular things, right? We're using Hyperledger Fabric because it's kind of a trusted network. Kubernetes and auto scaling, et cetera, and it's very robust architecture, right? It's resilient and recreates pods when they go down, all those kind of things. So Kubernetes is, we're depending on Kubernetes for a lot of that. A lot of security is built into the fact that we have distributed nodes, right? We don't need to worry about cordoning off data for carrier 1 because we can't even see that database, right? All we have to do is make sure that they agree that none of that data has any way to get outside of their node. Permission, right? So everybody on the system has to have the appropriate permissions as defined by Hyperledger Fabric to even contribute to the network. And of course, Hyperledger Fabric is the only way we're getting data across the wires. It's distributed. Hyperledger Fabric supports that, and that's one of the big decisions. Back to an earlier question about managed services. The managed Kubernetes service in Amazon doesn't support other clouds. Maybe that's changed since we had that discussion, but this is a very important aspect of the architecture. We need to be multi-cloud, as wherever possible, cloud agnostic. But if we have to do authentication differently on each cloud, then we'll just have to do different infrastructure as code for different clouds and provide a way to deploy that correctly. Manageable, as I mentioned, we're going to be pushing changes to remote clouds. So we need to put in place something to do that. And then of course, transparent. Everybody who's going to use the system needs to know exactly what's being put into their cloud, because we're not hosting it. They need to know exactly what's going on in their cloud. So the infrastructure as code is self-documenting. And then they keep that data in place. Again, because it's a carrier node, we never get to handle their data. All right, I have a couple more quick slides. We provided reference implementation running on Minikube, so you can kind of kick the tires and get a sense of how things work without committing to the cloud. And we'll also have a reference implementation in AWS as a result of our work with ChainYard, so that somebody using AWS can immediately get up. Other clouds are later on in the roadmap. So as you asked before, maybe there's more than 5 slides, right? What is the standard? The harmonized data store is not one standard, but it's a standard for every use, right? If you have a data call that's for auto, a data call that's for a different line of business, they can probably use the same basic standard, but there may be different ways to get the data in there, and they may mean slightly different things. But if we're using this for different purposes, like for regulatory reporting, the format of the data could change. So each use of this system could lead to a different standard. And as I mentioned, Dina Burgess is our director of BI here at AIS and in charge of the data standards for openIDL, and she'll be on one of the steering committees for the Hyperledger Fabric, for the openIDL project in Linux Foundation, so that there'll be a conversation about all of that over there. So then we talked about the harmonized data store. So how can you contribute? The data models, right? We'll need and want very much the input of everybody using this network to share data, to participate in these use cases. Those data models are going to need help from everybody to make sure that they're robust and include everything we need. The architecture, right? As we go into new clouds, we'll need help building the different cloud footprints, implementations of application components as they come along, accessing PPP, accessing census data. There is some technical debt in the system, of course, that will need somebody to do. AIS, of course, doesn't want to be the only one contributing to this. ChainYard is an example of an external vendor that's helping out, and other vendors have agreed to participate as we get new components, or if we get new organizations wanting to be part of the network. Those will need contributors to help them get onboarded. And of course, support, documentation, and testing are all things that we can use help. It's just a totally open source project. All the code's available in GitHub and available for viewing, etc. So what are we doing right now? We're migrating from the IBM Cloud to AWS, and again with ChainYard's help. We're creating the reference implementations, establishing those property and casualty harmonized data store standards, and we're building regulatory reporting. We currently have an internal system that does regulatory reporting. We're pushing that over to openIDL so that we can improve our footprint, make this more open the way that works. All right. Okay. I think that is, yeah, wait, I want to go one back. Yeah, there we go. So here's some URLs for getting involved, openidl.org. I don't have the GitHub. The GitHub account is, let me go over to it real quick, is openidl.org, openidl main, and all of the code for all of this stuff is out there. And we also have a Slack channel if anybody's interested. You can contact me, Ken S at aasonline.com, and or Truman, and you can go out to the openIDL org to see more information about the system. And you can become a Linux Foundation, part of Linux Foundation. Probably most of you guys are already. So with that, I'll open it up for questions. Less time than I was hoping, but so Jyoti, do we have some more questions? Jyoti, are you muted or? I think she's muted. We lost her. All right, let me see if I can see the chat. I'm gonna go from the bottom up. Okay.
Hey, sorry, Ken, I'm having a bit of a technical issues here. So sorry about that. Yes, there were a few questions, but I guess we are almost at the top of the hour. So if anyone has any pressing question, I would request for them to unmute themselves and ask.
Ken?
Hello.
Hi, this is Raj Sigamani. Excellent presentation, great work. I think we are making big progress with the Linux Foundation / Hyperledger Fabric. Also, I guess with IBM donating all of those as free source, open source is really excellent. I had a quick question for you in terms of the private data collection versus channel data. Where and how are you using them differently?
Right. So the default channel actually, we don't put anything on that private data collection that I can think of. The private data collection is used for the analytics channel when we're trying to share data across for reporting. So we establish a peer-to-peer channel between the data provider and the reporting node, and then the data provider puts the results of the extraction pattern into the private data collection, and that automatically goes over to the analytics node, and the analytics node sees the event and then processes it. Does that answer your question?
Yes, it does. But just want to clarify that the PDC is going on a different channel. Is that correct? Or a different interface?
It's going on the peer-to-peer channel.
Okay, thank you.
Hi, this is Angel. Great job. Real quick, can you just give us a little high level? What does your team look like before you started this project? What does it look like today? And from a technical skill set or upskilling standpoint, what are the areas that you had to invest in or bring in new people?
Sure. We started with IBM. IBM being I believe the originator of Hyperledger Fabric. Correct me if I'm wrong. I don't know the whole history. I think they contributed it to the Linux Foundation. We engaged with them before my tenure on this project to build the application. I think they went through a couple of iterations, found out you don't put too much data on the ledger, and the private data collection came online as during the process. We started using the private data collection. So we had a big IBM presence for a while. We've separated from IBM because certain different reasons, and we're now it's me and a couple other folks in AIS shepherding this into AWS with the help of ChainYard. I mentioned them more than I think probably could have hoped for. But they're experts in all the technologies that we're using. We have also engaged with other vendors. So our model going forward is to have a very small footprint inside AIS and depend on vendor partners and the open source community to build this out.
All right. If there are no other questions, we are at the top of the hour. Ken, thank you so much for your presentation today. As I said in the beginning, the session is being recorded on YouTube, Hyperledger's YouTube channel, and it's available for viewing after. Thank you, Ken, again for your time.
Thank you. Thanks everybody for attending.
Thanks, everyone.
Jyoti, is that chat available just for me to see later?
Yes, I have made the copy of the chat and I will be sending it to you shortly.
Okay, fantastic. Well, thanks for hosting. This was it was a good session.
Yes, it was a wonderful session. Thank you so much for your time.
Thank you. Bye.
Bye-bye.